Hey everyone, my name is Dhruv and I'm here to discuss my seam carving implementation. So a brief description of the algorithm is that we want to find seams in an image which are relatively low energy, and if we want to shrink the image we remove these seams, and if we want to expand the image along any dimension we duplicate these seams. And the reason we want to do the duplication or the removal at the seams is due to them being low energy, they will have a relatively low distortion factor on the image. And how we do this is how we find these seams are we first look at the energy of the image, which is basically we can use any sort of edge detector. Basically, we're just looking to get the gradients of the image, and then starting, let's say if we want to remove or add a vertical seam starting from the top of the image to the bottom of the image, we iterate through the pixels using this formula and finding the cumulative energy going from top to bottom. And once we have the cumulative energy matrix, we start backtracking from the bottom to the top to find the seam that had the least energy, and we can remove that or duplicate that seam, and we can repeat this process in order to expand or shrink our images. So let's take a look at the results that I got from my implementation. On the left we have the original, on the right we have my version, and they look pretty similar. Of course, like there are some differences where the original has more water, less trees. My implementation has more trees, less water. The second example is an expansion of the image where you can see my dolphins a little bit more jagged than the original dolphin, but it's definitely very comparable. And there's a special case of expansion when you want to expand the image more than 1.5 times, which is basically you repeat the process in steps. And over there, this jaggedness becomes a little bit more pronounced for the difference between my image and the original. And then this image is actually showing us the seams that got duplicated, and this is where you can see a significant difference, basically, that the seams that the author is detecting and the seams that I am detecting are definitely different. And this is the last result comparison, which is the TMAP optimization path TMAP. So I've definitely removed more seams than the author has, and our TMAPs also look pretty different, but the ultimate result I have here looks pretty good, I'd say. So I'd say the optimal seam removal is well done. And that's all I have. Thank you.